Hi class, welcome to the discussion over Chapter 1-3, Multiplying and Dividing Decimals, and we're going to be working with some properties of multiplication. The first topic we're going to be dealing with is multiplying decimals. And my best advice for students is just multiply as though there weren't any decimal points in the problem. Just ignore them when you multiply. Take care of the decimal point later. And remember that with multiplying, you have to add up the number of decimal places in the factors, and that tells you how many decimal places you need in the answer. So if we look at example A, 5 times 3 is 15. We regroup that 1. 5 times 4 is 20 plus 1 is 21. We'll regroup the 2. 5 times 2 is 10 plus 2 is 12. Then we're going to put a 0 underneath that 5 to indicate that we're now multiplying by a place value that's 10 times greater than we were before. So 2 times 3 is 6, 2 times 4 is 8, and 2 times 2 is 4. Then we add 5, 7, 10, so we're going to carry, and that's going to give us 6. Now, notice that here we have 2 decimal places. Here we have 1 decimal place. That means we need 3 in the answer. We are going to start from the right and count 3 over. 1, some people actually do it at first this way, 1, 2, 3. So our answer is going to be 6.075. Now if you don't want to trail it over with your pencil, you really don't have to do that. Let's look at example B. Well, 2 times 4 isn't hard, right? That's 8. Now, how many decimal places will I need in my answer? Did you say 2? Because that's correct. Now, again, we start from the right side. We need to go over 2 places. There's only 1 digit there. I have to put a 0 in there, and then my decimal point. Okay. There are also some properties of multiplication, and their applications, of course, with mental math. Just like addition, there's an identity property. This time, the identity element, as they call it, is 1. Some people call it the multiplicative identity. That's quite a mouthful. We also have a 0 property, and that's very important, is that anytime you multiply any number by 0, you are going to get 0. The commutative property, similarly to the one for addition we had the other day, on both sides of this, we would get 10. The idea is that for some people, to take 5 times 2 is easier than to take 2 times 5. Now my examples are pretty easy, but what if this were 5 times 12? That's much harder for people to think about than to take 12 times 5. The associative property, just like the one for addition, says that we can group things differently. All we do, we don't change the order of anything. All we do is change which ones we group together, or what we call associate. Now yes, for this example, it's no big deal that 6 times 5 is 30. But, again, what if this were 3 times 12, and then times 5? It would be easier to take 12 times 5, and then multiply by the 3. But for some people, even now, 6 times 5 is much harder than 3 times 10. How do we use this? If we look at our numbers here in example A, what stands out to me right away is that if I take 0.25, which is like a quarter when it comes to money, and then take it times 4, I'm going to get $1, which equals 1. So I'm going to commute. I'm going to change around the order of the 3.58 and the 4. So I'm going to get 0.25 times 4 times 3.58. Now I'm going to put in parentheses to associate, and now I'm going to get 1 times 3.58, and I'm using that identity principle now, and I'm getting 3.58. Look at example B. Can you see how it would be easier to not take this one exactly in order? Yes, to take the 5 times the 0.4 is a whole lot easier. That's going to be a 2. So if I use the commutative property to move the 0.4 and the 9.1 around, I'm going to make an easier problem for myself. Now if I also would consider putting in parentheses to associate this, I'm going to get 2 times 9.1. And that's going to be easier for some people to multiply mentally, because I can take 2 times 1, that's 2, and then 2 times 9, that's 18. And I need the 1 decimal place, so I put that in. Now my hint for you, I suppose, is look for factors that will help you obtain whole numbers such as 10, 100, 1,000, even something like 20, 30, 1, 2, anything like that will be very helpful. The last topic we're going to be dealing with today is dividing with decimals. Now, when we divide by whole numbers, then our decimal point just moves straight up. Now, can 6 go into 1? No, it can't. Once I have a decimal point placed, I have to have a digit in my quotient above every digit in my dividend. So I'm going to put a 0 up there. And 0 times 6 is 0. We just learned that for the 0 property. Now I subtract, I get 1. Now I bring down that 8. 6 into 18 goes 3 times, and 3 times 6 gives me 18. Now, I don't usually put the 0 down at the end if I know it's there. If you wish to, you may certainly do so. Okay, I look at example B. This is another whole number divisor, so that means my decimal point's got to go straight up. Now, 12 does not go into 4. Some people would put a 0 there, but I don't. 12 doesn't go into 4 at all, but it will go into 48 4 times. And then I bring down my 6. Does 12 go into 6? No. So I'm going to put a 0 in there. And 0 times 12 is 0. 6 minus 0 is 6. This is where I have to extend my decimal by putting a 0 to the right. Remember, that does not change your value when you put it to the right of a decimal. Then I bring that 0 down. And now 12 into 60 goes 5 times. And 5 times 12 gives me 60. What happens, however, when my divisor is not a whole number? If you recall, this means you need to make sure that your divisor is a whole number. So we move the decimal point in the divisor 1 place to the right in this case. Now if this were 1.45, I would move it 2 places. If it's 1.455, I would move it 3 places. Remember doing that in the past? Now if I do it in my divisor, I have to do it in my dividend too. So I'm going to shift, and now I can bring it straight up, because 1.4 has become 14. What I've essentially done here is multiply both the divisor and the dividend by 10. And that means I don't have to, now it means I can divide, because I really can't divide by a part of a number. 14 into 28 goes 2 times, so that's my 28. Then I bring down my 4. 14 does not go into 4, so I'm going to put a 0 above that. Then I'm going to bring down my 2. And 14 into 42 goes 3 times, and that equals 42. And now I have my problem done. One of the other things that's kind of nice when you divide decimals by powers of 10 is that you can actually use a shortcut of just shifting the decimal point however many places to the left as there are zeros in the divisor. Although remember, sometimes, just like with multiplying, you will need to add some zeros. So if we look at example D here, I am dividing by 10, which is 1 0. So I'm going to move my decimal point one place. 1 0 equals 1 place. Now remember, we want to go left. So I'm going to take this decimal point and move it one place left. Now, there isn't any digit here. That's where I add the 0. So I'm going to get 0.018. You try E. How many places are you going to move the decimal point? 3. What's my final answer going to become? 0.0045. If you want to draw that out, it's 1, 2, 3. Notice there's 2 places to put zeros, and that's why I have inserted 2 zeros between the decimal point and the 4. This concludes lesson 1-3. Catch you next time.